I'd like to give you a quick tour of around the YWAM's aquaponics system. The first one there on the right is a cone turns about every 7 minutes. In front of you is a standalone system with a radial filter in the blue barrel. Here is a new one. It's a little tote cut in half to teach how to make a practical aquaponics system out of one tote. The biofilter is on the top, and down on the bottom is the fish tank itself. And this one uses a very unique device that we come up with at Olomana Gardens. And this is the flushing device here at the bottom. We'll show it going off here in a few minutes, and it will roar. It uses a bell siphon up here on the top, so the water comes into the sender here to filter the sender, and then that is extra. If they had more rocks, it would just fill the whole thing up, and this should have a false bottom on it and then drain out. And to do that, they would put in some bricks and in some bread trays, 1/4-inch plastic netting, and then have all the rocks on top, and that would do it up. So this is just starting to set up. This is not complete yet. So you can see where the high tide mark is up there at the top, and they'll give you an idea of how long it'll take before it flushes. And these are the grow beds that they use. These are called float beds. Deep water beds are about 8 to 10 inches of water in them, a 2x12 frame, and they're doing CEA, Controlled Environment Agriculture. Notice they have an independent shade cloth on top, and that can be slid or open and closed with these rails here on the side. Kind of a neat little device here that clips on to the screen, and then pulling these screens you can pull it back so it doesn't bunch up on you. Pretty good. This is a vertical aquaponics system, uses the Olomana Gardens spray system inside. It's just been harvest cleaned up. They're doing some modification, and what they do is every group of students that come through, they will then modify it for it, and have them grow it out and test, and have kind of a competition between doing a vertical bed, doing a float bed, and different designs to see which one is more productive so they can see it for themselves. Here you see they do a higher shade cloth over it, about 6 feet of room underneath it. Over here, the black one in the background, that only have about 3 feet, and this one has a tan one. And so the students will see different percentages of shade cloth. Now there's several systems here. They have one big fish tank down at the bottom of the hill. I'm walking down toward it. It's in the far background back there underneath the building. And you'll see here they're doing their seedlings, so they put a shade cloth on them, and then they'll pull that back at different times as they grow up, as the plants harden up, and then they'll plant them over here. And if you want to see that, you'll see what size they are when they get planted. So the little seedlings get moved out here, as you see there, and then here you see them the next week, and here you come down here, and notice that they're dated. See, this is like October 30th, and you know that they're coming in, and when you jump up, here you are a week later, and there's 1 week in between each size, as you see here. And when you come down here, they're coming up, and it's edible at this point right now. And that would be babies, greens, and then you go to the full lettuce leaf here. And it's looking very good, very even growth going all the way around. In the background, you see they have onions in that. And this feeds a student body of about 1,200 students here at YWAM, University of Nations. Now we come over here. This is the fish tank itself. And you put the girls in here, that's to keep them from getting pregnant, because they don't want too many fish. And so here you see the tilapia over here in the water. Got a little floating rubber ducky, and that'll show us what current that we're generating. And that they generate the current by here. The return water is coming in here, and then when it flows, it rushes out. And they can put that into a directional pipe or go straight down for aeration. Different devices that they're doing. This one, the water will go straight down here, go down, come up, make a U-turn, go down again, and then you will have the bubbles. So it does a pretty good job all the way around. So it's a very solid building structure they have here. And then it allows the students to have different standalone systems. So over here they have separate fish tanks. Here they're using different techniques. You're using a galvanized tank, and they have a drop-in lining coming into it. Notice that they're using a lot of my air pumps from Olomana Garden, and this is an airlift, so you have a tank here, and the water comes out over here, comes into over here, bingo, and comes up, and that's the air release, and this is the water itself is coming out. Now when the water comes out, we come over here to the ground. Notice that the water can go down, go over, come over, and go up to where it needs to go. And so this bed will fill, and then this is the flushing mechanism, and this flushing mechanism will take the water back and come back over and go to here. So works out pretty cool. This is one of our unique Olomana Garden designs. I'm not even sure we put this in the book yet. It's kind of interesting. You get something, you get out and practice and prove it works before we write it up. But it's kind of neat here. So what you see is the bottom left here, I'll try to point with my finger here. Right here is where this pipe here, that's underneath here. This has a false bottom in it. So the water's going to come down, it's going to fill up, and the water in here is going to fill up to this level, overflow here, come down, splash, make bubbles. The bubbles are going to come out over here. The bubbles will be released to the air, the water will fall down, and bingo, she'll go all the way back to the fish tank. And you'll see it over here, and the water will flow back. Okay? So now what we have is a 1/4-inch hole drilled in the bottom over there, so that you're always drilling and taking a little bit of water out. Okay? And by doing that, if we had a power failure, it would drain this cinder, so it would not be sitting there in saturated static water. But that draining of just a 1/4-inch hole is not enough to interfere with the day-to-day operations. So you have, this is just a little mini system here. So this bed cleans that water in that tank. Then you can take the water from that tank and you can send it up over to other places because it's been treated, i.e. treated, and the ammonia has been turned into nitrogen, and then it feeds the float beds. So we need no additional filtration at that point. So you get all these different little systems tucked away so the students can see how different things work. I'd like to notice that YWAM has embraced the method that Olomana Gardens kind of pioneered, and that is always using a hose onto the air pump. And that lets you use these different things so they can switch the air. They can turn this one off, turn that one on, and this is one of our air pumps. But here, right now, they're running it. It's coming over here, and it's running this air pump, pumping the water up to here. Air goes out the top, water goes this way, and it goes over to this system. Okay? So it's neat. You always like to have the pump higher than the water. You would not want to set that on the ground. If you had a power failure, you risk it siphoning back. Now this is kind of cool. If I were to close this one and open that one, it would send the air over here, and that red hose out at the end. Now that can be connected to here. If it gets connected to here, and this is full of water, this is a displacement pump. If you put compressed air into here, this only goes in about 1/2 inch. So the air will be on top of the water, pushing down like a cylinder, and then it'll come out over here, come up, and you can hook a hose to there and go anywhere you want to. So they have a hose rig here ready to go. They just pop this on here, and bingo, they can pump that water anywhere they want to go. No barping or burping there. Pure displacement. This is our neat workshop area that they have going. On the far side over there, they have a tool room with keep all their tools locked up, but all the students have access to the tools. And here we're making up a spiral radial filter. That's our Thanksgiving Day project. We're going to do it up. This will coil up here, as you see here, we're starting to do. This will coil up, and as it coils around, then that will be stood up in a 55-gallon drum. So we'll complete that today and throw it into operation. It's a new experimental thing. This is vertical gardening. You take a garden like this, and you put it up here, and they'll fill it full of cinder or foam, and they'll just dribble the water down, and then the net pots just sit in here. So you can have hanging of Babylon gardens. How's that? Okay? So other little systems over here, the kids are allowed to, students, shouldn't call them kids or students. See, most of these students are, from teenagers up to 70 years old. So But most of them in the 20 to 40-year-old. They come here, they train to be missionaries at YWAM, and so they learn how to build different systems with different local materials. And that's what it's about here. And so it's kind of interesting to see the imagination they do. I'm Glenn Martinez of Olomana Gardens, and we like to come down here once or twice a year and kind of spur them on and show them what the new things that we're trying out and discovering, and then they put them into practice. Here, this one, that's the fish tank there. The water's coming out, comes over here, and this is a burper pump. The secret on this is right there, is that gray valve. That's a one-way check valve. So the water flows in, the check valve opens, the water goes in, the air is added here, it comes over here and it burps the water up. When I say burps the water up, I don't know if I can do this one-handed or not. I don't think so. On there pretty good. If this was clear, you see the water burping up in here, and then it's coming over here and it's coming into there. See there? And then this is their cinder bed. It fills up, and then the water comes over here, goes into there. And judging by the onions there, is doing a pretty good job of it. Now this is an Olomana garden trick we came up with. This is the double tray. This one is waterproof and has the drain going out the bottom. We throw in little pieces of 1-inch pipe into the bottom, and then this one is, the holes are all drilled out in the bottom, maybe 200-300 holes, 1/4 inch. And so this, well, the water here will fill up to this point here. When it gets to that point, it's going to flush. And when it flushes, it'll all go down. So this will fill up and flush about every 10 minutes, and the water will flush back. Now when it does it here, when it fills up to here, and it fills up there, it's going to come down over here, and then it's going to drain through these float beds, and then the float beds will return the water all the way back. So it's a continuous system. Works out pretty good for them. And so it's a unique system, standalone. So you go from fish tank to your ammonia to nitrogen cinder beds, you know, and that's called a false bottom system, and the dirty water comes in up from the bottom, okay, and it flushes out the bottom. So any dirt and residue gets moved to the float beds. The float beds overflow. There's a standpipe about 4 inches high in there, and then that water flows all the way back to the fish tank. Pretty clever, simple design, not too much to it, and pretty carefree and maintenance free. Up here is another little standalone system. You know, notice by putting the screen over here, they keep the birds out. It's just enough. Now, if they were to come down and tack it all the way down, they could keep the butterflies out and some of the other critters that might bring them some problem. As you see here, we can go Jurassic Park around here, right? And so they do a mixed bed in here. And this one, the water's coming here. It gets pumped up here in an air pump here, comes over here, fills up this drum, and this has a radio filter in it. So that inside there, it has little 5-inch legs on it. The water goes down, comes up to this level here, and this decants it and comes over here. Now that pipe in there you see coming up, it actually comes up about this high, okay? You know, a little bit higher than this. So it has to be higher than this. So you see how high the water is in here, and then this sets the level that'll be maintained at. So with that pipe coming up to here, all the dirt is settled on the bottom, and then periodically they'll pull the drain over here. They'll put a 5-gallon bucket underneath this one here, open up that black valve underneath there, and whoop, in 15 seconds all the dirt is out. So anyway, a neat little establishment. They also have in the earth gardens up there. They have composting piles and more and more. And I'll try to shoot a little videos on that. But it's a very nice environment. It even has a classroom area, and that's over here, Aquaponics, mission-focused training and research. So we do pretty good over here. We can do PowerPoint presentations on laptops. We have a drawing board so we can draw out what we're going to do. And it's got a nice ceiling fan. But this is a production area. You come over here on harvest day, this is one busy place. But very neatly organized. Cindy and Terry Stanton are the major champions of this, but they take it to Nepal and around the world. Anyway, hope you enjoy that, and we'll be seeing you next time. Glenn Martinez, Olomana Gardens, in the field at the YWAM University of Nations in Kona, Hawaii.